Hi, this is Brian Oliver. Welcome to the Coherence 12.1.2 Configuration Enhancements Part 4. In this part we're going to build something like Cron using a custom configuration namespace as a service for Coherence. So let's look at the agenda for today. So really we're just going to talk about three main things here. First we're going to look at creating the Cron service. I'm assuming everyone understands what Cron is as a timed service that runs in the background at some set interval. So we're going to use an external library to provide the actual Cron implementation, the scheduler, but we're going to integrate that using a Coherence custom namespace. As part of this, we're really going to dig into some of the cache configuration model, and in particular cache configuration lifecycle. So we're going to cover quite a bit of this in detail. And lastly, we're going to summarize some of the advantages and some of the capabilities that this lets us achieve. So let's create Cron as a custom namespace. To start with, let's just see what it may look like inside a Coherence cache configuration file. So here we're going to create our new Cron namespace. We're going to create a Cron namespace handler, much like we did in part 3. But this time we're going to create this new element here, the cron job. The cron job consists of a schedule. This is a standard sort of cron schedule, the number of seconds, minutes, hours, days, etc. when this task will execute, followed by the cron task itself. And here we're actually reusing the standard Coherence instance because we want to be able to specify some, say, runnable that will run on this schedule. And the way we've set this up is there could be many of these cron jobs specified in a cache configuration file. So let's step through how we're going to build this. So what's sort of the recipe here? Well, there are four things that we really have to cover here. The first one is, well, let's not reinvent the wheel. Let's not rebuild Cron. And luckily there's a really cool open source project called Cron4j that defines a very nice Cron implementation. It's quite simple. We could have used any other sort of scheduler as well. Quartz comes to mind. But in this case, we just want to use something simple, simple jar, very easy to understand, very minimal overhead and impact. So we're going to create a namespace, a custom namespace, pretty much like we did in part 3, the previous part to this series. Then we're going to create an appropriate element processor that will actually schedule a job with the scheduler. And this job will be a runnable in our case. But as mentioned earlier, we really need to work out how do we start and stop the scheduler as part of this sort of cache configuration that starts and stops. Imagine we're having to run, or we are running this configuration, our caching application inside a container, or inside some other framework, or inside, for example, the default cache server with Coherence. Then we really should be tied into the lifecycle of that container as well. So we want our scheduler to start and stop with the container in a clean manner. We'll cover how to do that. So let's get started. Very simply, the Cron namespace handler, much like our Hello World namespace handler, just extends the abstract namespace handler. And we've called super on start namespace as we did with our Hello World namespace handler from the previous series. But what we really need to do is create a scheduler for Cron, and then we really need to hold on to that reference because we're creating the scheduler, and that scheduler may be used in other parts of Coherence. In the past, we would probably declare the scheduler as a static variable and then just access it directly. The challenge is we may be running this application in, say, a container. It could be running in a cloud. It could be in a multi-tenant scenario. So creating a static may not necessarily be the right idea. In fact, it's something we want to totally avoid. So the first part of creating the scheduler instance is quite easy. We can just say new scheduler. But the second part is where should we place that scheduler so we can hold on to it as part of the life cycle of our cache configuration, but also so we can dispose of it, but also so we can start it and stop it in the necessary location. So where do we hold on to resources that we create in namespaces? What's the best way to do this? We know statics is not the answer. Well, we've talked about this in previous parts to the series. We briefly discussed the notion of a resource registry. We covered it in the first part when we talked about injection with injectables. But the resource registry is something new for Coherence 12.1.2, and essentially provides a type-safe named registry of resources, or objects if you like. There's no special interfaces for these objects to implement. They can be basically anything. It can be a string, it could be object, it could be a database connection, anything you like really. There are no special annotations. The resource registry itself is just a class that we use and is exposed pretty much everywhere. So for example, from Cache Factory, you can ask the configurable cache factory for its resource registry. Or while we're processing some XML in a namespace, we can ask for the resource registry. The important thing is these are scoped by the cache configuration, and in fact they're bound to the life cycle of the configuration. So any sort of resources, objects, beans, for example, that you place into the resource registry, say of a cache configuration, will be bound to that life cycle. Furthermore, you can receive callbacks when that registry changes in its life, when it's stopped, for example. So the resource registry interface is pretty much what you'd expect. It's pretty simple. You can either register resources, get resources, hence the implementing the resource resolver interface, or you can unregister resources. Resource registries themselves are disposable, and hence you can see in some of these signatures of these methods, you can be an observer to resource lifecycle. But let's just walk briefly through these methods. So the first one in the resource registry allows us to register some class with some resource. So I may register, say, a simple string. So I can say I want to register something, a string, with some particular string. Really the first parameter is about the interface that's used to identify the resource. So for example, I may want to register a database connection, yet the resource itself may be an Oracle database connection, or it might be a MySQL database connection. So the first parameter provides the class or the interface that's used to look up the resource, and the second is the actual resource. Now in certain situations where you have many implementations or many instances of the same resource, you may need to scope them by a name, and hence the second method allows you to provide a name for each individual name for each resource. In the first method, where a name is not provided, the default name is used, in which case it's just default. The third method explains or provides a little bit more capabilities. You imagine the scenario where there's many parts of a system that wants to register resources, and each may, for example, even attempt to register the same resource or a resource of the same type, but say for example you only want a singleton. So this third implementation, this signature, allows you to specify the interface, the class of the resource, and provide a builder. Tell the resource registry how to actually build the resource if it's required to build one. The third parameter specifies the behavior, whether it should be built always, whether it should be ignored if it's already there, and so on. And the fourth parameter specifies an observer that could be used. So for example, when the resource registry is being shut down, you can receive callbacks to tidy up your resources if the resources themselves don't implement this interface. You notice all of these methods actually return a string when you register a resource. The string that's returned is the actual name that was eventually used to register a resource. And this is very helpful for the last method, which allows you to unregister resources. The fourth method is really just much like the second method, in that it allows you to specify a name together with a builder and a resource behavior or registration behavior. So this is basically a resource registry. It's very handy and allows us completely to avoid the use of statics when customizing coherence. So let's go back to our cron namespace handler. So one of the things I mentioned before, we can actually get the resource registry from the processing context. So we're going to register our scheduler as a resource with our configurable cache factory. Now, this is the resource registry that the configurable cache factory will eventually have. So here we say, get the processing context, get our resource registry. Then we can register our resource. Well, we're going to register the scheduler class in this case, but we're going to provide a builder. So in this case, we're saying, I want to be able to build a scheduler, and if the resource registry finds that there isn't a scheduler already known to it, it will call realize, which essentially builds our scheduler for us. However, if by chance the scheduler has already been registered with a resource registry, then the behavior will be to ignore this registration and carry on. At the end here, we've said we don't want a resource a listener when the resource registry is shut down. Although we've said we do want to know about this, we'll see how we deal with this shortly in the next slide. So when and how do we start and stop the scheduler? So we've created an instance of the scheduler, but how do we actually start and stop it? Say, for example, when our cache configuration is being processed. Or say we're inside a container when we deploy and undeploy an application. So this brings us to another major point. Now we actually have an entire presentation on this concept, but we're going to briefly describe this in one slide. Coherence 12.1.2 introduces the concept of live events. Live events essentially provide us with information about server-side activities and lifecycle. There are many different types of events that Coherence provides out of the box now, and it's all done through a consistent framework. The cool thing here is that we can actually intercept these events, either just to observe them or in fact to change server-side behavior. Now for us, what we really want to do is know when the server has finished reading the cache configuration and has basically started services, if you like, or when it's being undeployed. So how do we register an interceptor? Well, pretty much like the resource registry, there's an interceptor registry. So how do you get a hold of the interceptor registry? Well, there are many ways. But basically the two that are most common are using the processing context. The interceptor registry is actually a resource in the resource registry, funny enough, but also the configurable cache factory now has a new method called getInterceptorRegistry. We'll be using the first in this case. So let's go back to see how we would intercept the sort of activation of an application and disposal of an application if it was, say, running in a cache server or in a container. So now, continuing on with our method, we say interceptor registry get resource from the resource registry. So resource registry get the interceptor registry. Once we have the interceptor registry, we can say register an event interceptor. And in this case, we're going to register an event interceptor for lifecycle events. And this is one simple method, on event, obviously passing in the lifecycle event. Now, the lifecycle event has a bunch of information. One being the configurable cache factory in which it occurred. And the nice thing about that is it lets us get the resource registry again. Once we have the resource registry, we can then determine our scheduler that we'd previously registered. Because we don't know when this event is actually going to occur. We may load the cache configuration, we may define all the jobs, we may create the scheduler, but the application may actually be undeployed, or there may be some delay between loading, parsing the configuration and deploying. So we can't do it all at once. So we wait until we get the activated event before we call scheduler.start. Now once the scheduler started, then any jobs that have been added to scheduler will start processing. Now of course, if we undeploy or we shut the cache server down, then we'll get a disposing event, in which case we should cleanly shut down the scheduler by calling stop. Now of course, similar, all of the registries we have, we've introduced have this notion of registration behavior. So should it be the case that this interceptor is already registered, we can tell the interceptor registry to ignore the registration of this. And that's our onStart namespace method. So what about the actual cron job itself? We've dealt with the case where we've started the namespace, we have registered a scheduler, we've created it and registered it. What about adding jobs to the scheduler? So we now need to sort of deal with all of this XML stuff. And how can we deal with that? Well, in the previous examples we talked a little bit about defining element processes. So what we really need to do is define an element process for job. We may need to define ones for these other elements. But this one here, instance, that's actually built into Coherence, so we won't need to do anything for those. Let's look at how to create job. So very much like what we did in the previous examples, in the Hello World namespace, we now define an element processor. In this case, our element processor isn't actually going to return anything. It's just going to process the job, in which case, and add it to the scheduler. And in this case, we know that this is an element handler for job. So again, we define the process method, and this is where we leverage the processing context. The processing context actually contains a huge amount of functionality for dealing with processing XML. Certainly in a way that means you don't really have to do any processing of XML. So for example, let's say I wanted to get the schedule that's defined in the string. So we can say to the context, get the mandatory property. It's called schedule. It should be defined in the element or perhaps attribute called schedule. And it's going to be a string. We know that the type has to be a string class, and it's going to be defined in this element. This tells the processing context to look in this element, find the schedule, and make sure it's a string. If it's not, it will actually throw a configuration exception for us. And it will say something nice like, expected the schedule of type string in element blah blah blah, and so on. The next part is dealing with task. Now really what we need for task, we need something that's going to, well, return a way of instantiating some class, or providing us with some instance of some class. So we know that the element is called task. But what is the task? If we go back, we say in this case it was instance. But imagine if we were using Spring, this might be a Spring Bean. The reality is we don't know what this could be, and we want to allow it to be anything. So Coherence defines this concept of a parameterized builder. So we want to process task, and whatever's inside defined in the elements, we expect it to implement a parameterized builder. So if it can't find task, it will obviously throw a configuration exception. And if it can't find a parameterized builder, it will actually throw an exception saying expected a parameterized builder. But in this case, let's assume it actually returns a parameterized builder. Now, of course, we don't know what type it is, hence it has to be a question mark. It has to be a wildcard. It's a parameterized builder of something. So we now have our schedule and our task, but we need to get our scheduler back. So we can ask the context. The processing context has the resource registry as well, so we can ask the resource registry. It turns out it's the same one that was used that we created earlier, so hence I can get my scheduler back. Notice it stops us having to either change these methods and pass through different contexts, so for example the scheduler. It also saves us from defining static methods. So the resource registry is a nice way to hold on to state and make it available throughout the system in a type-safe way. So I now have our scheduler. Now, of course, what we really need to do is schedule this job, so schedule our task. So we can ask the builder to realize whatever it has, whatever it's been defined. So in which case, it will create an instance of my runnable. So here we say builder realize, and there's the numerous parameters that the builder can take in. How to resolve any other parameters that may be defined by the builder. What's the class loader that it should use if it has to load the class, and any constructor parameter arguments that you may want. In which case we don't really care, and it's a null constructor. So assuming that's successful, we'll actually get a task back. Of course, we still don't know what it is. So if it's actually runnable, we can tell the scheduler to schedule the runnable using whatever the schedule we provided up above. But if it's an instance of a task, and this is a special Cron for J interface, then we can schedule a task. So every time in our cache configuration it sees a cron job, it's going to execute this bit of code, which allows us to parse out the schedule, get the builder for our task, find our scheduler, build our task, and schedule that task with a scheduler. And that's essentially it. That's our entire cron namespace handler. So now let's see it in action. So let's start by just looking at my runnable. My runnable is just really going to say hello world. It's just going to say hello world for my runnable. And in our example configuration, we see that we're going to schedule our cron job just as we have in our slides. So let's switch to our cron for J base server. This is the default cache server that's just configured to use this example. And now let's run this. So in this example, we can see that Coherence has started up, and at this point here, we've started the cron service, or starting the cron service, then it is started. And we can see at this point in time, we've actually run the runnable, and it says hello world. And if we wait around a minute or so, we will actually see that it runs every minute, just as the cron schedule has said. So let's fast forward in time and see what the result is. And there it is again. We've run our runnable again. Spot on, exactly when we expected it. We can happily leave that running in the background as we continue our presentation. So let's look in summary. So Coherence 12.1.2 introduces this concept of custom namespaces. This is really handy for integrating third-party frameworks, especially like Spring, as we've shown in the previous presentation. But it also allows us to develop new extensions for Coherence. For example, in this case, the cron extension. We can use custom namespaces to allow us to add these extensions directly into Coherence without having to define different servers, run separate JVMs. In the past, if you wanted to run cron, you'd probably have to start a separate cache instance. You'd probably have to start a separate Java application. In this case, we can embed these things directly into Coherence itself, thus making them highly available. Ultimately, it allows the complete customization of Coherence. As during the processing of content, your XML, you have complete access to the resource registry and all the resources like the actual cache config, the interceptor registry. You can customize the behavior of Coherence through your own namespaces. Coherence 12.1.2 also introduces this notion of live events, a server-side framework for intercepting events as they occur. This is particularly good for lifecycle notification. It allows us, and combine these two things can allow us to avoid having to define statics, and it allows us to run side by side in multi-tenant environments, certainly inside of containers. I hope you've enjoyed this presentation series. We may provide some new ones further down the track, but for now, this is what we've achieved so far with custom namespaces and the Coherence 12.1.2 cache configuration enhancements.